8:36 is our time. Rider University joins a groundbreaking mission to map the universe like never before. The Vera C. Rubin Observatory, perched on a mountaintop in Chile, has begun its 10-year quest to create the most detailed map of the cosmos in human history. With its massive 3.2 billion pixel camera, the observatory is already revealing galaxies, nebulas, and thousands of undiscovered asteroids undiscovered until now. Rider University is part of this global effort, opening doors for students and researchers to explore the universe's biggest mysteries, from dark energy to the search for a possible ninth planet. Yeah, we're not talking Pluto. That's no longer a ninth planet. They've ruled that not a planet. So we're looking for an actual ninth planet. Joining us now is Dr. John Bochanski, who is Associate Director and Chair of Rider's Department of Computer Science and Physics. Dr. Bochanski, it's good to have you on. Good morning.
Yeah, good morning, Ken. It's a pleasure to be here.
And you know what? The more I read about you online and all you've done and all that happens at Ryder, I started to get a headache because I realized how much thinking is involved. And when you see these teeny tiny dots that move that much from night to night, I'm like, how do your eyes spot that and say, oh, that's an asteroid? Is it just does it help in the era of computers to help find this stuff?
Oh yeah, absolutely. To do the kind of project that we want to do with Rubin and the Rubin Observatory, you definitely need computers to make it happen. You mentioned the asteroid project. That in and of itself is going to be groundbreaking. There's going to be a census of the solar system, unlike one that humanity has ever had. To date, we know of about 1 million asteroids. Some of those are ones that zip by us every once in a while. One of those had a really bad day for the dinosaurs. But
Mm-hmm.
after Rubin has done its observations, we're probably going to add about 5 million asteroids to that original 1 million. Just
The
to give you a
goal here,
sense of,
Doctor, I
yeah,
don't mean to step on you. The goal here is to
yeah.
prevent, or in the event that there's an asteroid that could be headed right for us and do to us what it did to the dinosaurs. Is that the idea here, to keep an eye on every one of those asteroids?
It's a good side benefit for the science. The astronomers on the project are really just excited about learning how the solar system has developed and grown over time, and just getting a really good census of what is out there is the first step, and that's what the Rubin Observatory is going to provide for us.
So, talk about what makes this project so unique and why it has the potential for Nobel Prize worthy discoveries. Is it because of the size of the telescope, the integration of computer technology? What is it that makes this so unique?
So it's not the biggest telescope ever made. But it is the scale of the project is probably the largest ever undertaken. So you're talking about thousands of people all over the globe, including many folks in New Jersey, that have contributed to the project. We are using the largest digital camera ever made by humanity. As you mentioned in the intro, it's about 3.2 billion pixels. It's not going to fit on your phone. And it's about the size of an SUV. And to build something like that takes a lot of effort. And the duration of the planned mission is over a decade, and that is also unique in astronomy.
So you're talking about, when you talk about the people around the world, excuse me, doctor, this is part of the LSST Discovery Alliance. Is that what that's called?
Yeah, so the LSST Discovery Alliance is a group that supports the mission of the Vera Rubin Observatory. So it has to do a little bit with exactly how you can do fundraising. But to give you a sense of the scale of the project, I was just at a meeting in Tucson, Arizona. There were approximately like 500 people there, and that was a small fraction of the actual number of folks that are involved with this project. So there are thousands of astronomers all over the globe that are really excited to be using this data. And what's great about it is, like, for the first time, I've been talking about this project since 2008 and thinking about it in terms of the future tense, but it's here now. right? We're taking data, we're delivering these products, and we're exploring the universe in a way that's never been done before.
I love this. And pardon me, doctor, little frog in my throat today. You had mentioned, you said 3.2 billion pixels, not your smartphone, or at least not your smartphone yet. Give it a couple of years. I'm sure the smartphones will have 3.2 billion pixels. It's headed that way. And of course, back in the day, because I was so into astronomy as a kid, I remember the earlier astronomers, I mean, they used photographic plates, and all you needed was like a speck of dust getting on the photographic plate, and then you were wondering, well, is that something I'm seeing or not? That doesn't happen in the world of digital anymore, obviously, because we're not developing film clearly. And that's what makes this so fascinating to me, because that's kind of where I left off when they were still using photographic plates. The observatory now is hunting for answers about dark energy and dark matter. What is that about? And then even a ninth planet. When I was a kid, Pluto was the ninth planet. In early 2000s, they said it's not a planet. So what are we looking for? Basically, shifts in the different orbits of our planets, assuming that there would be a ninth planet. Is that how that works?
Yeah, so I'll talk about the ninth planet first, and then get back to dark matter and dark energy. There's growing evidence that there may be a ninth planet in the outer reaches of our solar system. Not Pluto, but Pluto's neighbors have been jostled around, and show patterns in their orbits. And so one of the explanations for that jostling and the patterns that we've observed, is the potential existence of a ninth planet. This thing would be about the size of Neptune. It would have a weird orbit compared to everything else that we know in the solar system in terms of planets. But we haven't seen it yet. Is an ideal discovery engine for Planet Nine. This
It's fascinating.
the way that it operates, it's going to take 30-second images and basically repeat that process and mosaic the entire night sky over about 3 nights. And then it's going to repeat that process for 10 years. And so we're going to get really good coverage of what's happening in the universe, over a time scale that we haven't explored before. It's essentially going
Would
to
it?
be
Would
the best movie of the
I'm sorry.
universe
Please
ever.
continue.
Yeah, so it's definitely going to be a game changing data set. Now we talked about the solar system for dark matter and dark energy. Dark energy is really the big question mark. It makes up most of the universe. We don't know what it is, but we do see its effects. Essentially, it's causing the universe to expand and accelerate in that expansion. It's an outward pressure, if you want to think of it that way. Um, this was only discovered, to give you a sense, I went to Villanova University, graduated in 2002, and this dark energy was discovered right around when I was starting undergrad. And
Amazing.
um, Rubin has a very, very good chance of telling us more about what dark energy is, its properties, and how it's changing our universe.
And I don't mean to go back to that potential ninth planet, but I'm guessing if it's as large as you're mentioning, the size of Neptune, is it that we haven't been able to see it yet because it's so far from the sun that it's dark, it's not reflecting much light, and that's why you need to have 30-second exposures and probably the combination of the visual data from all of the observatories of the planet? Is that am I kind of on the right track? Is that why we haven't seen it yet?
Yeah, definitely. Yeah, so it would be very far away. It would have what we call an eccentric orbit, so it would spend most of its time actually really far away compared to the rest of the planets. And so planets don't emit their own light; they reflect light, and so these things are extraordinarily dim. You need a lot of coverage in terms of area on the sky and time sampling in order to get those little tracks. And to get back to like your first point about asteroids, that none of this can be done by eye anymore. What you do is stitch together images and look for the things that are moving. And so we have a sense of what the orbit of Planet Nine should look like if it is there. And Rubin is going to be ideal at finding this thing if it is
I
there.
love it. And you met, right? You met Vera Rubin, the astronomer for whom this observatory is named. How did her work inspire you? And what do you hope this project will do to inspire the next generation of scientists?
Yeah, so I did have the pleasure of having lunch with Vera at the Carnegie Institute of Terrestrial Magnetism down in DC a number of years ago, and she was just the nicest person, really welcoming to a young scientist like myself at the time, and her work and her spirit in terms of how she persevered um, through institutional barriers. Right, she had a hard time actually getting a job in astronomy, and she really paved the way for a lot of female scientists in astronomy today. Um, it's a perfect namesake for her. She should have gotten a Nobel Prize for her work. She was one of the first people to discover the existence of dark matter. Unfortunately, that didn't happen. But what really inspires me at this stage of my career, I got three young daughters at home. They're all interested in science and astronomy. Go figure. But you know, this project is going to be ongoing when my oldest daughter gets to college, and if she wants to pursue science, having a data set that's public and open to all and is a very inclusive group is really going to be something that I think changes the way that at least astronomy is done here in New Jersey.
Go for it. Absolutely. I could talk to you for hours about this, doctor. I'm so fascinated. I'm that guy that goes down the Google and YouTube universe and just watches video after video after video. And so I would break into one of your classes and sneak in the back and just listen for hours. I'm so fascinated by it. Please come back again, Dr. John Bochanski, Associate Professor and Chair of Rider University's Department of Computer Science and Physics. Thank you so much for joining us and all the best with the project.
Yeah, thank you, Ken. Have a good day.
You, you too, sir. Thank you.